Well, hi folks. This is hopefully an easy introduction into some of the very basic concepts of causal loop diagrams. Where we're heading with this is providing ourselves with some form of diagram that allows us to understand the interactions between the various elements of a system. So let's look at some very basic ways to show how we might come up with a way of diagramming and representing the effect of one element of a system on another element of a system. So we're going to start off with something that's pretty straightforward. Here we have a lovely cloud delivering some rain to a dam, sometimes called a tank in Australia, a dam on a farmer's property. Water's a very precious commodity in Australia because a lot of it's very dry. So we get very interested in this. Now there's a very interesting relationship between this. If we go the rain, if we have rain falling, we could say one of the things that gives us is water in a dam. So you might be able to begin to imagine that up until the limits of the size of the dam, the more rain that falls on the dam or in the surrounding areas that feed the dam, the more water we will get in the dam. One of the things you'll find out as we go through these causal loop map diagrams is that the way we choose these terms is very important. If you're doing the reading, as you will be, of course, you'll find that they need to be nouns, and they need to be something that we could ultimately measure if we could. Here we can measure the volume of water in the dam. And here we can actually measure the quantity of rainfall, so that's usually these days measured in millimetres or centimetres of rain. So we can actually measure the, well, let's call it rainfall, and we know that that's going to be measured in some quantity. Now, it's a very basic example, but this allows us to start setting up some of the aspects of how we want to represent the relationship between the rainfall, the quantity of rain falling, and the volume of our dam. There's an interesting thing here that we can say, in this case, it's really obvious, which is why I'm starting with this one, the more rain that falls, up to the limits of the dam, the greater the volume of the water in the dam. The less rain that falls, the less, or the smaller the volume of water, or the lesser, it would be a better word, but I'll write smaller there, it makes sense. So the less rain that falls, the smaller is the volume of water in the dam. Here's an interesting point. We could actually choose a different label here. We could in fact in this case say not the volume of the water but the increase in the volume of the water. So that would be another quantity here. So the less rain that falls, the less the increase in the volume of water. One of the things, if you get into the complicated areas of working with these causal loop diagrams, is that you'll find that the labeling that you choose is very important, because you think about it differently, and some of the debate that goes on with creating these causal loop diagrams and system diagrams is what is the best label. But let's just stick with rainfall and the volume of water in the dam. Notice there's an interesting relationship here, that the direction of change of this quantity, the rainfall, and the direction of change of this one, the volume of water, or if you like the increase in volume of water, is the same. So if I get more of this, I get more of this. If I get less of this, I get less of this. So we want a way of representing something on these arrows that actually tells us that. There are two ways we can do it. Because the direction of change is the same, sometimes we'll use just an S to say more of this means more of this, less of this means less of this. The other way, the other symbol that you'll more frequently see in these is a plus sign. This is just a convention. In this case, That doesn't mean add anything up, it just means that the direction of change of this one is the same as the effect, the direction of change in this one. So more of this means more of this, less of this means less of this. Let's look at a slightly different example in a moment. So now let's look at this one. Here's a nice hot Australian summer. We can often have very hot and long and dry summers. And here we have our sun in a good mood shining down on our dam and the water's evaporating off the dam. In a similar vein to the previous one, we could actually say, we could talk about, similar to the previous example, just to continue on, just to give you an example of picking the right terms, here we can be actually measuring the amount of radiant energy. You can measure that in joules or flux of electromagnetic radiation or a number of different terms, but radiant energy is a quantity that we could measure. Over here, we can have the rate of evaporation. Notice I've said the rate of evaporation rather than just evaporation. We're going to get some evaporation anyway, but in this case, it's a more meaningful term. So what's the relationship between this? Well, the more radiant energy falling on the dam, the greater the rate of evaporation. The less radiant energy falling on the dam, let's suppose we get a cloudy day that comes in and covers the sun, you get a nice cool cloudy day, then the rate of evaporation will be less. So the relationship between this is a same relationship. So more of this means a greater value on this one, less radiant energy falling means less on this one. The other way of representing this, you'll remember, is a plus sign. And all that means is that the relationship of the change of this quantity is the same as the relationship of the change of this quantity. Now let's look at something very slightly different from that. Let's change the labels a little bit. Or let's move them around. So let's change the relationship. So I'm going to move this one over to the other side and say the rate of evaporation and on this side I'm going to put volume, being the volume of water, the volume retained. I could just say volume, but it's more meaningful in this case to say the volume of water retained. Because, and now we can start to examine this relationship and compare it to this one. The greater the rate of evaporation, what will happen to the volume retained? Well, if you could watch a high rate of evaporation, which by the way is going to depend on radiant energy and wind and things like that, but let's just state this, the greater the rate of this, the more that is, the faster you'll see the dam dry up. The slower the rate of evaporation, the greater the rate of volume retained, or the greater the volume retained in any given time. So you'll notice that this one, the way we've drawn it, is an opposite direction. So more of this, a greater rate of evaporation means less of this, a smaller volume retained. So this, we can put an O here for opposite. Notice that, so we said more of this, less of this. If there's a slower rate of evaporation, or if you like a lower value on this quantity, so less of this, we would retain more volume of water. So that's an opposite direction. So more of this means less of this, less of this means more of this. or a greater value on this quantity. And we indicate this one with that sign. So if you see an O or a minus sign, it means the relationship of the change of this quantity is opposite to the change in this quantity. So more gives you less, or less gives you more. Whereas where you see the same and the plus sign, more gives you more and less gives you less. Let's summarise that for you on the next sheet. So let's take a generic quantity A and quantity B. This might be heat applied, this might be the heat applied and rate of boiling of water, for example. This might be the quality of training for people in an organisation, and this might be the productivity of the organisation. So our first type of relationship is where we have the direction of change of the measurement of one quantity is the same as the direction of change of this one. So if this one, whatever value we met, whatever metric we're applying to this, whatever we're measuring this in, is if this increases, this one will also increase. And we indicate that either with an S or a plus. So if this one goes up, this one goes up. If this one goes down, this one goes down. So the measurement there, so if our quantity of heat applied to some boiling water is reduced, the rate of boiling will also be reduced. Now let's compare that with this one, for example. So here we have quantity A, quantity B. Let's suppose in this example, quantity A is the number of people calling in sick for work, and this might be productivity of the workplace. So you might imagine that the more people who call in sick, the lower the productivity, or the less the productivity. So more of this means less of this, so we have an opposite relationship. So we can indicate that on the arrow with O or with minus. If we have fewer people calling in sick, then we might expect that the productivity might increase. So less of this, or fewer people calling in sick, means more productivity. So that one goes down and this one goes up. So you can see we have an opposite relationship in the movement or the change, direction of change of this quantity compared to this quantity. That's the very basics of the two types of diagram, two types of lines we're going to use to show the effect of the change in one quantity on another. We only need those two. From this, in future videos, we'll be able to look at how we form loops and begin to examine entire systems. Just to give you a quick feed forward or quick preview of what that might do, let's have a look at this. So starting to match up a couple of these things. Let's label this one here, as you can see from the diagram, that says cough. Number of employees calling in sick. And over here we'll put the number of people, number of employees available for work. So immediately we could see a relationship between this, that the number of employees calling in sick has to affect the number of people available for work. What type of relationship? Well, the more people who call in sick for work, the fewer people you have available for working. So more of this means less of this. The direction of change of this, more, is opposite to the direction of change of this, less or fewer. So this is a negative relationship or an opposite relationship. what does this do to productivity, however we're measuring productivity. Productivity might be the number of reports pumped out per day, might be the number of mindless forms filled out each day, it might actually be the number of gadgets that a particular manufacturing plant produces per day, for example. The number available for work, you might hope that generally the more of this, the greater this will be. You'll get a better measure for this. The more of this you have, the more of this you have, the more of this, or the better this is likely to be. So that if we increase this, we'd expect to increase this. If we decrease this, we'd expect to decrease this. So this is a same relationship. So we could use an S, or as you'll probably see more often, the plus sign. You can see here that we've now got the beginning of starting to see how things interact in a system. This, we could actually go directly from this to this, but we actually go, well, what's actually happening in the system? So we go, the number of employees calling in sick, we might have a sense that that affects the productivity. Well, how? Well, the more people who call in sick, the fewer people we have available for work, and then as that drops, so will the productivity. So one of the types of things you're going to be asked is if we increase the number of employees, what is likely to happen to the productivity in the organisation? So can we follow the arrows and the effects as indicated on the arrows to work out what's going to happen here? Well, more of this means less of this, because that's an opposite relationship. Now, less of this, we have a same relationship. Less of this means less of that. So if we increase the number of employees, we, by this chain of effects, end up with lower productivity. So one of the things you'll need to understand and will be able to, or will want to be able to answer in the exam, will be able to answer in the exam is, can you follow, if we increase this or decrease this, what does this tell you about what will happen over here? And from that, depending on what's happening here, what does this tell you about what's going to happen here? So there's our brief introduction to causal loop diagrams. There's a lot more in the reading that you've got to do.